Okay, so question number 8. Draw the Lewis structure of the sulfate ion SO42-. How many valence electrons are present? What is the electron group geometry and molecular geometry? What are the bond angles? And is it polar or nonpolar? Okay, so this is question 8. And we first need to find out the total number of valence electrons for SO42-. So this is part A. So sulfur has 6 valence electrons, and oxygen also has 6, and we have 4 oxygen atoms, so we multiply this by 4. And we also need to take into account the overall charge of the ion, which is -2. So we need to add an additional 2 electrons to our electron count, which gives us a total of 32 valence electrons. So this will help us in writing the Lewis structure. So we'll have sulfur as our central atom. And let's see what happens if we were to draw out the 4 single bonds to oxygen and filled in all of the lone pairs. So if we were to calculate the formal charges of all of the oxygens, when we have a single bonded oxygen, it has a formal charge of -1. And we want our overall charge of the ion to be -2. But if we were to bring a pair of electrons down on 2 of the oxygens to form a double bond, then the overall charge of our ion would be -2. Okay. So now our Lewis structure looks like this. Okay, so part B says what is the electron group geometry and what is the molecular geometry. So to analyze this, we'll look at our central sulfur atom, and we'll see that there are 0 lone pairs and 4 bonded atoms. And by using a Vesper theory table, we can find out both its electron group geometry, molecular geometry, and the bond angles. So we'll see that when you have 4 bonded atoms, 0 lone pairs, the electron geometry is tetrahedral. And for C, molecular geometry is also tetrahedral. And the bond angles are 109.5 degrees. So lastly, is the molecule polar or nonpolar? So oxygen is more electronegative than the sulfur, but if we look at our molecule, the dipole moments would cancel each other out. So therefore, SO42- is a nonpolar molecule. Okay, so the junior tutor said there are 32 valence electrons, and they have the correct Lewis structure by completing the octet of the central sulfur. According to Vesper, it has a tetrahedral molecular shape and electron geometry. The individual dipole moments are cancelled, making the ion nonpolar. Okay, so this solution is correct.